Hey guys, so I just wanted to go over the notes with you. So we're starting with observation and inference. This we went over today or yesterday. Observation is something that you witness, whether using your five senses. So sight, smell, hear, taste, touch. An example would be, I see a man with a red shirt, or um, I smell sour milk. I hear a car screeching. I taste chocolate, or I touch a rough surface, or I touch a wet surface. And based on your observations, that'll give you an inference. You can base your inference on your observation. So, like for example, I smell sour milk. So that means that somebody either left the milk out, or maybe like a baby dropped the bottle in the car and it got sour in the car. So inferences are things that, or there are ideas based on your observations. Okay, so now we're going to go into some new stuff. So density. So basically what density is, it's the amount of stuff or the mass that's packed into a particular space. So the example that we give is a book. A big book doesn't take up that much space, but if you go to pick it up, it has some heft to it. So a book has a small amount of volume, but it has a larger amount of mass, as opposed to a beach ball. So a beach ball, it takes up more space than a book, but it's not nearly as heavy. It doesn't have as much mass as a book does. So in this particular case, since the book has more stuff packed into a smaller spot, we would say that the book has a higher density. So the higher the density is, the more stuff is packed into that space. The lower the density, the less stuff that's in the space. Like for a beach ball, it's mostly air. So it has a low density. Things that have a low density, if they're less dense, they'll float. Things that are more dense, they'll sink in water. Okay, so now we're going to practice. I'm going to show you guys how to do some density problems. So the formula for density is actually right on the front page of your reference tables. So on the front page of your reference tables, you have this little thing here that says equations, and the density formula is density equals mass divided by volume. So here it is. Density equals mass divided by volume. So density is the number of atoms divided by the space it occupies, if you want to just change the words a little bit. To find density of an object, we would use a balance to get the mass of it, and a graduated cylinder for a liquid, or a ruler for something that has flat sides. When you're solving for density, it's important that you use the correct units, because you could do the whole question right, but label it with the wrong units, and you wouldn't get credit for it. So since for a liquid you have to use graduated cylinders to get the volume, we're using milliliters, like a 3 liter of soda, or liters, a liter of water. So for liquids, we always use grams per milliliter. For a solid that has flat sides, we would use a ruler, and we would measure it in centimeters. So we'd get the volume, which would be length times width times height for volume. So in that case, we use grams per centimeter cubed. Okay, so if you're asked to solve for density, it's really simple. It's basically mass divided by volume. But a lot of times, you're going to be asked to solve for volume, or you're going to be asked to solve for mass. So in that case, we always like to use this little triangle right here. So whatever you're solving for, what you do is you literally cover it over. So for example, if you're solving for density, you put your finger over the D, which I'm going to put the cursor over the D. When you put the cursor over the D, you see that there's an M, which is up here, over V, which is down here. So solving for density, it's mass over volume. So you take the mass, the number for mass, and you divide it by the V. So the example we gave you here, if you have a mass of 2 and a volume of 1, so that would be 2 divided by 1. 2 divided by 1 is 2 grams per milliliter. So since the mass is 2 and the volume is 1, it'd be 2 divided by 1, and you'd get 2 grams per milliliter. Okay, so now if you're solving for mass, So if the question asks you to solve for mass, you're going to take your finger and put it over the m. So once you cover the m, you're left with the d and the v. When you have these two letters here, you're simply going to multiply them. So say, for example, the density of an object is 5. The volume is 10. So we have a density of 5. We have a volume of 10. You cover over the m since that's what you're solving for. And you simply take the 5 grams per milliliter and you multiply it by the 10 milliliters. So in this case, you have a mass, the mass would be 50 because 5 times 10 is 50. So if you're solving for mass, you cover over the m. You're left with the d, the density, and the volume. Since they're next to each other, you can act like that's a multiplication symbol right there, or an x. And it's density times volume equals mass. Okay, if you're solving for volume, what you're going to do is you're going to cover over the v. So we have this v here for volume, and we have mass over density. So if you're solving for volume, you take your thumb or your finger, you cover the v, you're left with an m over d. So in this case, you're going to take the mass and you're going to divide it by the volume. So let's say we had a mass of 10. So you'd have a 10 up top and a density of 5, a 5 on the bottom. So you'd have 10 over 5. So 10 divided by 5 is 2. So 10 divided by 5, the mass is 10, the density is 5, so 10 divided by 5 is 2. So the volume would be 2, because 10 divided by 5 is 2. So therefore the volume is 2 milliliters. Okay, one other thing to note, which I did not mention on the last slide, is that the two G's, they cancel out. We have a 10 grams for mass, we have a 5 grams per milliliter for density. This G cancels out with that G, and you're left with the milliliters. So if you're solving for volume, your answer is always going to be milliliters or centimeters cubed. If you're solving for mass, you're always going to be answering in grams, because that's how we measure mass. If you're solving for density, it's going to be grams per milliliters or grams per centimeter cubed.